So activity 4.3 continues our discussion on quadratic functions. So let's take a look at the book's example. It says statistics from the U.S. Department of Commerce lay out the per capita personal income of each resident in the U.S. from 1960 to 2000. And the T represents the time in years, or the number of years, since 1960. Right? We're given P of T represents the income, and T represents the number of years since 1960. So we're asked, what is the practical domain? Well, if we're going from 1960 to 2000, and T is the number of years since 1960, well, 1960 would represent 0, and 2000 would represent 40, right? The difference here is 40. So the domain will be T somewhere in between 0 and 40. So there's our practical domain. Question 2, it says let T equal 0 correspond to 1960, and we're asked to use our calculator to complete the following table of values for T. And then we're going to round our output to the nearest dollar. So right away, T at 1960 is going to be 0. At 1965, we'll have 5. 1970 is 10 years after 1960, and so on. So I filled in the values for T, right? 0, 5, 10, 15, and so on. Now to get the values P of T, well, if I plug in or substitute the value 0 for T and solve for P, that will give me my answer here. And if I take a 5 into T and solve for P, that would give me an answer here. But an easier way would be, why don't we graph this and then use the table feature on our calculator to come up with all of the answers for our table. So I'm going to get my graphing calculator. I press Y equals. I clear everything out. And then I enter my function. So here's the equation entered into my calculator. And now, since this table seems to be counting by 5s, I want to set my table up to count by 5s. So I'm going to press second and the window key, because above window it says table set. I want to start my table at 0, and I want to count by 5s. And now when I press second and graph, well, there's my table, 0, 5, 10, 15. So I can simply put in 1,831 for my P here, and for a 5, when T is 5, I have 2,704, and so forth. Right? So all of my values for my table are going to come from here. So when I transfer the information from my calculator to my table, these are the results. Question 3 says, sketch a graph of the function, and then they give us the window. X-min is -5, X-max is 45, and so on. So we've already entered our equation into the calculator, so I'm just going to set my window by pressing the window key. So here's my window, and I press graph. And if we've done this correctly, we should have a graph that looks similar to what's given to us in the book. Right? Yeah, these graphs appear similar, so I feel comfortable about what I've done here. Question 4 says, estimate the income in the year 1989, or when T is equal to 29. So if I have my calculator here, if I press the trace key and I press 29, it's telling me, okay, when X is 29, my Y should be, and it looks like 17,432. So here's my answer. I could have also went to my table, right? Instead of counting by 5s, I could count by 1. And if I start at 29, well, my table will show me, okay, what happens, right, when X is 27, 28, 29, right? When X is 29, my Y is 17,432, right? So we could use the graph, or we could use the table. Question 20 says, okay, we want to know what year will the income reach 20,500. Write the equation to determine the value. Okay, let's do that. So this is the equation we would have to solve, right? We would have to solve this equation for T, right? We know what the income is. It's 20,500. We just don't know the T, or the year when the income will reach 20,500. So the two ways we can solve this would be numerically or using the table, or we can solve this graphically. All right, so the numerical approach, we're going to graph both sides of the equal sign. All right, so I take out my calculator, I press y equals. So the right side of the equation is already in our calculator, and the left side is this 20,500. And what I'll do, again, I want to make sure my table is set up to count by ones, and in this case, I'm going to start at 0. So I'll start at 0, I'll count by 1. I press second in the graph key. And now what we want to do is we want to see, when does y1 equal y2? Right? If I scroll down, it looks like it's happening somewhere in between years 1 and 2. Actually, it's not between years 1 and 2. That's 1,945. We're looking for 20,000, so we have to scroll down quite a bit. See, here we're at 4,000, 5,000. We need to get to 20,000. So it looks like when we get to year 32, y1 and y2 are equal. So in what year will the income reach 20,500? It looks like 32 years after 1960. So that's going to be our answer for question number 6. What is your approximation using this approach? Using a table. Again, it looks like in year 32, or 32 years after 1960. So here's my answer for number 6. Now, if we want to solve this graphically, right, question number, no question. Right below question number 6, they talk about solving the same equation graphically. Right? So if I pull up my graphing calculator, we already have the right side of my equation and the left side of my equation. The intersection should be my answer. Right? So the intersection of these two lines should happen at 32. Right? Now the thing is, my window, if I recall, I just want to make sure we went far enough. Okay, my x-max is going to a number bigger than 32, so that looks okay. So I'm going to graph. There's one curve. Here comes the second curve. And to calculate the intersection, press second, and above trace there's a calculate button, right? We're going to calculate number 5 is the intersection. My first curve, right, that's the 15.144x squared and so on. I'll press enter. My second curve is the straight line, which is 20,500. And then my guess, well, it's somewhere around here. I'll press enter. And when x is 32, y is 20,500. Now, some people might say, oh, what about this 47? Well, if we were to round 32.000047, we'd get 32, right? So that's close enough to 32 to suffice. So we've just solved this problem now graphically, right? We used the table method to come up with a 32 originally, and then we graphed both sides of my equation, right, the left side and the right side, and we found the intersection to also be 32.